All right, in the last video, we were finishing up this problem and I didn't have time to find angle B. So now we're going to find angle B using the information that we were given, using A and C. So angle B, we've got the adjacent side and the hypotenuse. So that would be cosine. So the cosine of angle B is going to be 18.9 over 46.3. So to find the angle, we're going to use the inverse cosine of 18.9 over 46.3. And that is how you find those. I'm not going to plug these into my calculator. It will just take too much time to figure that out. I'm going to move on to the next problem that you'll see on the test, and that is problems with bearing. Okay, so bearing can be represented in two different ways. First, if you're just told something is moving along a bearing of 27 degrees, what does that mean? Well, it means that from north, when you draw your coordinate axes, remember north, south, east, west, from north, you are moving 27 degrees in a clockwise direction. So you're moving like this. 27 degrees. All right, that means whatever this is, a plane or a ship or whatever, is moving along this vector right here. So what is 312 degrees? Well, you do the same thing from north, east, west. From north, we're going to move along, go 312 degrees around. So this is 270. So I need, let's see, 42 more degrees. So I'm right here. So this is 312 degrees. So that's one way that you could obtain bearing of a plane or a ship, or the bearing from one city to another. Another way of representing bearing is by actually giving directions. The first letter here is always north or south. The second letter here is always east or west. Okay, so the first letter tells you where to start. Are you going to start north or are you going to start south? So in this one, we're going to start north. And then we're going to move in an easterly direction. From north, we're moving 21 degrees. So whatever it is we're looking at, or whatever's moving, is moving along this vector. What does south mean? South. Instead of starting at north, we are going to start at south. And we're going to move 52 degrees in a westerly direction. So that is like this. So that would be about 52 degrees. So those are the two ways that you can represent bearing. If you're not given north or south, east or west, the letters, you always start north and you move in a clockwise direction. If you are given north or south as the first, east or west at the second, then you start on that pole and move towards either east or west. So let's take a look at one of the problems that you might see on your test. So we're going to set it up. We may not necessarily plug it in our calculator, but we'll solve it all the way down to what we would plug in our calculator. It says two ships leave a port at the same time. So I'm going to draw my little port here, and I'm going to draw my north, south, east, and west directions. It says the first ship sails on a bearing of 40 degrees. So here we're not given north or south, east or west, so we know we're starting from the north, and it's sailing at a bearing of 40 degrees. So it's along here. This is 40 degrees right here. And it's traveling at 18 knots every hour. So it says then the second ship is traveling along a bearing of 130 degrees. So now 130 degrees, so this is 90, so 40 degrees into here. So this is the second ship right here. So this is 130 degrees, and it's traveling at 16 knots. And it asks how far are they apart after an hour and a half. So 18 knots after an hour and a half, that's 1.5 times 18, so that's 27 nautical miles. 26 knots an hour and a half, that's going to be 1.5, that's 39 nautical miles. So we need to find the distance between the two ships. So we need to see if this is a right triangle. Well, I know if this is 40, this, since this is 130, this is my 90, this must be 40 here. All right, so this part is 50 in here, 40 plus 50, that's 90, plus my 40, this is going to be my 90-degree angle right here. So this is a nice right triangle. How would I find the distance between these two ships located right here and right here? Well, I just take their side lengths, which is 27 nautical miles plus squared plus 39 nautical miles. If I take the square root of that, I get the distance that the ships are apart after an hour and a half. So here, let's take a look at this problem right here. It says 2 lighthouses are located on a north-south line. So let's draw the first lighthouse. Let's draw the second lighthouse. I'm going to call this the first. I'm going to call this the second. It doesn't really say that that the first one is north of the second one, but we'll take a look at the bearing and make sure everything makes sense. It says from Lighthouse A, the bearing of a ship 3,742 miles away is south 50 degrees 17 minutes. So if I draw in my north, south, east, west, I'm starting from the south and I'm moving 50 degrees 17 minutes towards east. So somewhere out here is the ship along this line. From Lighthouse B, the bearing of the ship is north. So if I draw my north, south, east, west, starting north and moving towards east, 39 degrees 43 minutes. Somewhere along this line is the ship. So this is where the ship is. It's where the two lines intersect. So this is 39 degrees 43 minutes. This one is 50 degrees 17 minutes. So I don't know if you noticed, but if I add these two angles, this one here, the red angle and the green angle, they add to 90 degrees, which means this is a nice right triangle. So it does say from Lighthouse A, the ship is 3,742 meters away. So this is 3,742 meters. This is my ship right here. It says find the distance between the lighthouses. So they want us to find the hypotenuse. I don't really care which angle you use. So it doesn't matter whether you use Lighthouse A, the red angle, and use cosine to solve, or Lighthouse B, use the green angle. I usually choose sine, so I'm going to go with the sine of 39 degrees 43 minutes equals the opposite, 3,742 meters over D. So D is going to be 3,742 meters over the sine of, and remember in parentheses, 39 plus 43 over 60. So if you plug that in, it'll give you the distance between the two lighthouses. All right, so let's do a different kind of problem right here. And this is the last type of problem that you're really going to have on your house. You're going to have solving right triangles, solving problems with bearings, solving problems that produce right triangles, like maybe a ladder against a wall, or maybe an antenna being held by a guy wire, but they produce right triangles. So this is the last type of problem that you're going to have on the test. This is typically a more difficult problem because we don't have an entire side of either of these right triangles. So we have two right triangles here. We have this big right triangle, and we have this small right triangle. So the question is, how can you solve for h if you don't know a complete side? Well, you can always solve for h if you know part of a side and you know some angles. So here we go. Let's call this side x. So we know this entire side here is x plus 168. So let's go ahead and find, let's see, opposite over adjacent, that's tangent. So the tangent of 41.2 degrees is h over x plus 168. Well, now if we do the same thing for this triangle, right? Opposite over adjacent, the tangent of 52.5 degrees is h over x. Now if we solve for x in one of these equations, we can plug in x into the other equation. So I'm going to take this equation and I'm going to solve for x. So if I multiply both sides by x and then divide by the tangent of 52.5 degrees, I get x equals h over the tangent of 52.5 degrees. Now I have a value that I can plug in for x here. Okay, and now I can solve for h once I do that. And remember, we created a system of equations, 2 variables, 2 unknowns, and I'm using the method of substitution to solve. So the tangent of 41.2 degrees equals h over the tangent of 52.5 degrees plus 168. So we have to get rid of this complex fraction, so let's go ahead and multiply by the tangent of 52.5 degrees on both sides. So I get the tangent of 52.5 degrees, tangent of 41.2 degrees equals, let's see, wow, that's not really what I wanted to do, is it? No, that was not too bright of me. Let's go ahead and do, well, I'm going to erase this. What I really wanted to do is I wanted to multiply by the tangent of 52.5 degrees over the tangent of 52.5 degrees. So it's h tangent of 52.5 degrees over h plus 168 tangent of 52.5 degrees. So now if I multiply both sides by this denominator, h plus 168 tangent of 52.5 degrees, h plus 168 tangent of 52.5 degrees. So I'm just going to go ahead and distribute this, and my denominator over here goes away. So I get h tangent of 41.2 degrees plus 168 times the tangent of 52.5 degrees times the tangent of 41.2 degrees, and that's going to equal h times the tangent of 52.5 degrees. So what I really need are my h's all on one side, so I'm going to subtract this guy and move it to the other side. So I have 168 tangent of 52.5 degrees, tangent of 41.2 degrees. That equals h tangent of 52.5 degrees minus h tangent of 41.2 degrees. So now I'm going to go ahead and factor out the h. And I know these are kind of a pain in the butt problems, but we're going to have 1 on our test. So make sure that you know how to do that. And I need to factor that out, because if I don't factor it out, I can't solve for h. So now I'm going to just divide both sides, and I get 168 tangent of 52.5 degrees, tangent of 41.2 degrees, all over the tangent of 52.5 degrees minus the tangent of 41.2 degrees. When you plug something like this in your calculator, make sure that you put parentheses around the numerator and denominator, or you may be getting an unexpected answer that will not work. All right, so I went over all the types of problems that you're going to see on your test. You're going to be asked to find the reference angle. You're going to be asked to find the cosecant or secant of a particular angle. You're going to be asked to find the angle of, like, cosecant of theta, where cosecant of theta equals a certain number. You'll need to be able to do that. You'll need to be able to solve right triangles. You'll need to be able to solve problems that produce right triangles. You'll need to be able to do bearing problems, and you'll need to be able to solve for h in a problem like this. And that is what Chapter 2 test will all be about.